I'd like to go over some of these test 2 problems, especially the ones that were of difficulty to a lot of people. So, a couple of factoring ones. For the most part, the factoring was pretty good. The tricky factoring ones obviously are ones like 2h here, and 3c gave people a lot of trouble also. Right? Now 2h is really just one that you had to memorize the form for. 2h is one of these, it's a sum of cubes. Right? This is really of the form a cubed plus b cubed. And when you have something of the form a cubed plus b cubed, it factored into a plus b times a squared minus ab plus b squared. Again, that was just pretty much a factoring formula that you had to memorize. So in this case, a is the cube root of 125x cubed, which is 5x, and b is the cube root of 8, which is going to be 2. So this thing is just going to factor into, there's the form a plus b, which is 5x plus 2, and then it's a squared minus ab plus b squared. So if a is 5x, a squared is going to be 25x squared. If b is 2, b squared is going to be 4. And then in the middle, you just get the opposite of a times b. So a times b would be 10x, and I'm going to write this as minus 10x. And the nice thing about these is you can always multiply them out to check them. And when you multiply that out, you got to obviously, distribute. You got to do 5x times this, 5x times that, 5x times that, and then 2 times all those things, all those three terms. And what ends up happening is everything cancels out except for the 5x times 25x squared and the 2 times the 4. Right? So that's what you end up with. And again, that was just a formula that you really pretty much had to memorize. Okay, now 3c, and the key here was, you see how I said factor completely, and I put the stars around the word completely? What that pretty much was a hint about was that these are all going to be two-step problems. Right? So x to the 4th minus 16, you can look at that and say, all right, it's difference of two squares. Sure, it is. So it factors into x squared minus 4 and x squared plus 4. Now x squared plus 4 is a sum of squares, so that's not going to factor anymore. But x squared minus 4 is a difference of squares, which is going to factor again. And that factors into x minus 2 times x plus 2, and then you just bring the x squared plus 4 down into the answer. So that was your answer there. X minus 2, x plus 2, x squared plus 4. Okay. Now, most of these other ones in part 1 were okay. Even 6 and 7 weren't terrible. A lot of times, people have a lot of trouble with those. The thing you have to remember with 7, though, I'm not going to go through the ones in number 7, but I'm just going to point out to you the idea here, and see it was even in the instructions, so there was really no excuse for people that didn't do it. Write your answer as a single simplified rational expression. And a rational expression means it's a fraction. So like a lot of people, for example, in B, the answer I believe was something like x squared minus x plus 12 or something like that. I'm just guessing. If it's wrong, I apologize. I think it was x squared minus x plus 12, and some people left it at that. But it's x squared minus x plus 12 over the common denominator, which was x minus 4 x plus 4. 8, I guess 8c I can do, because a lot of people have missed that one. So 8c now, the first thing is you got to get an LCD, and of course what happens is x squared plus 5x plus 6 just factors into x plus 3 times x plus 2, which means that the LCD here was really just 6 times x plus 3 times x plus 2. So what you did is you multiplied both sides of this by 6 times x plus 3 times x plus 2. And you can do a lot of writing with this problem if you want to, but I think that just causes a lot of trouble. So bottom line with this is what happens when you multiply this LCD by the first term here, the x plus 3 and the x plus 2 cancel out with the x plus 3 and the x plus 2, and you just are left with 6 times 1, which is just going to be 6. And then when you multiply it by the second term, this x plus 3 cancels out with this x plus 3, and then you're just left with 6 times x plus 2 times x. And then on the right side, the only thing that cancels is the 6. So you're left with x plus 3 times x plus 2. And if you got that far, I think I probably gave you half credit. You probably got at least 1.5 points out of the 3. Because now there's still a decent amount of work left, though, right? So now that you got to distribute this. And FOIL on the right side. And now set it equal to 0 because it's a quadratic, right? The nice thing here is that the 6's cancel, so there's no constant. So I subtract x squared and subtract 5x, and I end up with 5x squared plus 7x equals 0. And then this is just a GCF. I can take out an x, and then I'm left with 5x plus 7 equals 0. So I end up with x equals 0, or x equals negative 7/5, and they both work because neither one of them will make the denominator 0. Right? That was the only thing you had to check for in these, is that you got to make sure that they're not extraneous solutions, meaning they would make one of the denominators 0. But 0 doesn't make either denominator 0, and neither does negative 7/5. So both those solutions work. Okay? And then 9, what I found funny actually with 9 is more people got B right than got A right. And A is actually an easier one. The way that I like to do these complex fractions is I just multiply the numerator and denominator by the LCD. All right? Now the only thing that's tricky here is in A, there's really only one denominator. It's x. Right? Because 3x plus 12, you can look at it as having a denominator, but it's a denominator just of 1. So the LCD of the numerator and denominator here is just x. So all I really have to do in this one is multiply the top and the bottom by x. And in the top, I had to distribute, and I get x plus 4. And in the denominator, I'm going to leave that in factored form. Okay, I'm going to leave it in factored form, so I'm not going to multiply it out. And actually, 3x plus 12 itself can even be factored. So I can take out a 3 there, and I'd be left with 3x times x plus 4. Again, I'm not writing out everything here in the interest of space and time, right? So now what happens here is the x plus 4 that's in the numerator cancels with the one that's in the denominator. So I'm just left with a 1 in the numerator and a 3x in the denominator. So that's my solution. It's my simplified fraction there. It's just 1 over 3x. Right? 13, I mean, that's kind of something that if you don't know how to solve the equations by graphing yet, you should look in that technology module in Canvas, because it's very simple, really. I mean, there's no reason for you to lose points on this. Any equation to solve graphically, just enter one side as y1 in your calculator, the other side as y2 in your calculator, and then I gave you a window to use. So the window I give you to use is going to show the solutions. So all you then have to do is use your calc intersect, and that's how you can get your solutions graphically. Alright, 14 was pretty good for the most part. That wasn't that bad of a problem. 15, okay, just filling in the table, giving the solutions. 16, not bad, except I think, again, the idea is some people don't realize that you were really solving an equation here, and the equation you were solving was 50 equals negative 16t squared plus 90t plus 4. So you should have entered one side as y1 and the other side as y2, and then do calc intersect. Right? I think some people are using trace, and if you use trace, you can kind of get pretty close to the solution, but you can't get the precise solution. So you have to use calc intersect. Whenever you solve anything graphically, you need to have two graphs, and then you can do calc intersect and not trace. All right. So please practice solving those equations graphically, because they're really, I think they're really easy problems. There's really no written work involved in them. It's just a matter of graphing and then doing calc intersect. Okay, and then 17 was a bit of an issue, and I was a little bit upset about this actually, because of the fact that I told you that I was going to have this on the test, and a lot of people didn't know how to do it. Right? I sent you that email telling you that this was going to be on there. So you're dealing with a right triangle, and the thing to remember was I told you here that angle C is the right angle. Generally, you always assume C is the right angle, and then you just label the other two sides as the other two angles as A and B, right? And then the idea is little side A is always going to be opposite angle A. So if this is angle A here, side A is going to be here. And if angle B is here, this is side B here. And of course the hypotenuse is always opposite the right angle, so that's always little c. So in this case, we know that B is 28 degrees. So A is the easy part, right? If B is 28 degrees, A is just going to be 90 degrees minus 28 degrees, right? Because the two acute angles have to add up to 90, so 90 minus 28 is going to give you 62. So honestly, if you set up this picture correctly and then you got A equals 62, you had 2 points out of the 4, right? Without even doing any trig. But now the problem is, if you're going to find, let's say, side B, right? And I know that side A is 14, and I know that angle B is 28. If I have this angle here, I'm trying to find this side, which is opposite. And this side here, I know, which is the adjacent. So I know the adjacent, and I'm trying to find the opposite. So what trig function involves opposite and adjacent? It would be tangent. So I would do the tangent of 28 degrees here equals the opposite, which is B, over the adjacent, which is 14. And now if I cross multiply here, I'm going to have B equals 14 tangent of 28. And then I would just do that on the calculator. Right? On the calculator, 14 tan of 28. Just make sure I'm in the proper mode, right? Degree mode, which I'm not. You gotta be careful there. And that's going to give me 7.44. So side B is 7.44. And then to find the hypotenuse, which is C, again, if I'm using 28 degrees, I know the adjacent is 14, and I'm trying to find the hypotenuse. So adjacent, hypotenuse, I would use cosine, right? Remember SOHCAHTOA? So the k of SOHCAHTOA, that's adjacent over hypotenuse. So the cosine of 28 degrees is going to be the adjacent, which I know is 14, over the hypotenuse, which I'm trying to find, which is C. And now here, if I cross multiply, then I have to divide by the cosine of 28. So I'm going to have C is 14 divided by the cosine of 28 degrees. So C is going to be 14 divided by the cosine of 28. And that's going to give me 15.86. And does this make sense? Yes, because the hypotenuse should be the longest side, and the bigger leg, which is A, should be opposite the bigger angle, which is 62, which makes sense, and then the smaller leg, which is 7.44, should be opposite the smaller angle, which is only 28.